Hello, grade 7s. Welcome to another week of school. Today we are going to keep learning about how to use formulas when finding area. So we're on using formulas part 3. Before we start, I would like to point out Wyatt's name and Sam. Their names are up there for having done their homework, so good job, guys, and everyone else who did their homework on Friday. And I would also like to welcome 2 new students that we have to math class. So today we have Lucas starting, and he is joining us while the public schools are off, so he will be with us as long as we continue working online. So welcome, Lucas, we're glad to have you, and welcome to Kobe as well, who started last week, and he is also with us while public schools are out. So welcome to both of them. So, okay, let's get started. So we are looking at using formulas. So let's just remember what some of the formulas are that we know. So we figured out how to find the formula of a parallelogram, for example. So we found out the area of a parallelogram is base times height. Okay, and we found out for a triangle, the area is base times height divided by 2. And we already know the area of a rectangle is length times width. So, okay, so we'll just put those in brackets there, parallelogram. Okay, so we have these formulas, and as a reminder, the reason why we would use a formula is that it makes things a lot quicker. So we don't have to look at a problem and try to figure out how we find out the area. We can look at what we have and we can think, well, I know that this formula works, so we can plug our numbers in and find our answer. So it makes things a lot quicker without every time having to figure out exactly how you would find out what the answer is. We can use these formulas. So let's go over some problems together. Okay. So we've gone over, so if you have a question and you know what the base is and you know what the height is and you know it's a parallelogram, then you put those numbers in the formula and you get your answer. But what if you don't have everything? What if you don't have base and height, but you have the total area? How would you find that out? So we are going to explore that. Okay, so let's look at a question here. So let's say we know what the area is. The area of a rectangular sheet of foil is 25 meters squared. Okay? And we know that the width is 75 centimeters. What is the length? So in this case, we're not looking for the area, we're actually looking for the length. We know what the area is and we know what the width is. So let's do our steps. So remember that our first step is that we circle the things that we know. Let's focus on what we know, because often we can get discouraged thinking, oh, I don't know how to find this. Let's look at what we know. So we know it's a rectangle, and we know that the area is 25 meters squared, and we know our width. So we know quite a bit. We know what the shape is, so that means we know what the formula will be, and we know the area and the width. What are we looking for? We don't know the length, so let's underline that. Next, we'll draw a little sketch. Okay, so it's a rectangle. We know the total area equals 25 meters squared, and we know the width is 75 centimeters. We don't know the length. So the third step was the sketch. The fourth step is to figure out what formula we will use. So we're looking for area. No, we have area and it's a rectangle, so we will use area equals length times width. Now what we would normally do here is that we would put in our number for area and we would put in our number for width, and then we would solve for length. But before we do that, we have to change some of the units. So if you look at it, the area is in meters squared and the width is in centimeters. So we have to decide do we want to change the meters to centimeters or the centimeters to meters? Now, either way is fine, and you will get the same answer either way. The only thing you have to remember about converting meters squared to centimeters squared is that 1 meter squared is worth 10,000 centimeters squared. But if we had, okay, so 1 meter squared equals 10,000 centimeters squared, but 1 meter is equal to 100 centimeters, okay? So you have to just keep those in mind when you're converting so you don't get mixed up. So just keep that in mind. All right, so why don't we keep these metered squares here, and we'll change 75 centimeters into meters. So that's easy because you need 100 of them to make 1 meter. We don't have 100, so we move in 2 spots and we'll have 0.75 meters, okay? So let's fill this in. So we have area is 25 meters squared, and that equals length times width. We don't know the length, but we know the width is 0.75 meters once we've converted it, okay? So let's rewrite that, except we'll write 0.75 times L. We'll do a capital L so it doesn't look like a 1 here. Now, so what we're really saying is 0.75 times something equals 25. So we're thinking to ourselves, what do you multiply this by to get that? Now, if you're not sure what to do, what you could think of is picture a question you do know. So let's say this was 25 equals 5 times what? Well, you know it's 5 times 5. How would you find that if you didn't know? You would divide 25 by 5 to get your other answer. So what you're going to do here is divide 25 by 0.75, and you can use a calculator for that. And then you will find out what this missing L value is. So if you try that and you divide that, what you're going to find on your calculator is that it's 33.33 meters. So those 3's keep repeating, so you can stop it there. So the length is 33.33 meters, okay? And yeah, so that's that question. So if you're struggling with that at all, feel free to go back and re-watch that. That one's a little tricky because of the conversion. Let's try one where we aren't converting numbers or converting units. We'll try another one here. Okay, so let's say we have this isosceles triangle. And the base is 5 centimeters and the area is 30 centimeters squared. What is the height? Okay, so let's go through our steps. So what we do when we find a word problem is that we think, what do we know? Well, we know it's a triangle, and we know the base, and we know the area. So, and then step number 2, what do we not know, or what are we looking for? Here, we do not know what the height is. Okay. Third step, we'll draw a little quick sketch. So we draw an isosceles triangle, and the base is 5 centimeters, and the area is 30 centimeters squared. And you can see that in this case, both measurements are using centimeters, so that's great. We don't have to worry about converting. Okay, and what we don't know is this height. Okay, so we're going to try to find that. So now the fourth step, what we think about is, can we think of a formula that we know that will help us solve the problem? So yes, we know the area of a triangle is base times height divided by 2. So now what we can do is take these numbers that we know, plug them into our formula, and we will have one letter left that we don't know. That will be our variable that we're solving for. So let's try that. Okay, so we've got 30. We'll just drop the measurements for now since they're all the same. 30 equals 5 times the height divided by 2. Okay, so we need to get to this h all by itself. So if 30 equals this divided by 2, then we could say that 60 equals 5 times h without that. Okay, so what you can do is multiply both sides by 2, and then this will be saying this times 2 divided by 2, that just cancels out, doesn't it? So this times 2 is 60. So 60 equals 5 times h. Okay, so then we say, okay, 60 equals 5h. If you say 5h, that's the same as 5 times h. So you remember that from earlier in the year when we did a unit on algebra. Okay, now 5 times what equals 60. So we could say 60 divided by 5. Divide both sides by 5. We'll get h equals 12. And then let's try that back in our original formula. So the base was 5. 5 times 12, that's 60. Divided by 2, does that equal 30? Yes, it does. So we found our height. Our height is 12. Okay, let's try one more problem here. And then I'll let you know what you're doing for homework today. Okay, so we have a parallelogram that is 25 centimeters high. Okay, and we know that the area is 1.5 meters squared. What is the length of the base? Okay, so again, we have a problem where we actually know the area, but it's one of the factors going into the area that we don't know, and that's no problem. We can solve this. So let's circle what we know. We know it's a parallelogram. It's 25 centimeters high. We know the area. We don't know the base. How long is the base? So we can find that out. So let's draw a quick sketch. Parallelogram is 25 centimeters, and the area is 1.5 meters squared, and we don't know what the base is. Now again, this is one of those problems where we have some centimeters and some things in meters, so we need to convert one or the other. So we can either convert this to meters, which would be 0.25 meters, or we can convert this to centimeters squared, which would be, what is that, 15,000 centimeters. So I'd like to stick with something smaller, so I would stick with converting this to meters, but you can do it either way. Either way is fine. Okay, so we know what the formula for a parallelogram is, so let's write that down, and we can find that quickly. So base times height. So we know 1.5 is the area, and we don't know the base. Base times 0.25. Now that we've converted that to meters, it's 0.25. Okay, 1.5 equals 0.25 b. So again, what we have to do to get this b alone is divide both sides by 0.25. You can do this on your calculator, but you could also do it in your head. So if you think 1.5, if you thought of that as $1.50, and you thought of this as a quarter, how many quarters would fit into $1.50? Well, that's 6. So base equals 6. And then look back at the units that we were using, meters. And it's not squared. The area is what has a squared sign, but for base it's 6 meters. Okay. So that is your last example for today. I will write the homework on the board here, and if you have any questions, please email me and I will get back to you and it can help you out. But feel free to watch the video over and try things over. And yeah, I think you guys have been doing well, and I think you'll get it. Okay, so for homework, you are on page 180 to 181, numbers, I'd like you to try numbers 11, 13, 16, and 24. Okay, so great. Have a good day, and I'll see you tomorrow.